I want to talk about end-to-end 3D avatar capture in the wild, and in particular I want to talk about the challenges that we faced with end users capturing themselves in the wild. We enable everyone to scan themselves at home just with their smartphone and then use a photorealistic 3D avatar for any real-time 3D application like games or telepresence in VR, for example. A short demo of this. As you can tell, we capture a few different angles of the person, up, down, left, right, also a few face expressions, and then after a couple minutes of processing, you get basic 3D asset with mesh, texture, and now also with hair strands. That users are not very familiar with 3D scanning, so you really need to guide them through the process. So most users won't have the best ideal lighting conditions available to them, and we need to deal with this somehow. That we can only capture like the frontal part of the face, because that's what the users can do, but we want a 360-degree head scan basically. So this guiding process already ensures that we have like a basic level of scan quality. So what's very, very common is that someone has strong ceiling light, and some people also wear hats, other accessories, caps, and then some users also want to keep their glasses on. The light conditions change between the different angles, and we trained a model that actually uses this effect. We trained a model that takes all of these as an input, and it produces this quite clean output diffuse texture. But then we do another step that is trained separately and applies super resolution to get a nice 2K or 4K texture as an output. And now if you render it onto an avatar, you can tell that the texture is quite good quality. And the new method is actually also trained to not only remove glasses, but also remove any texture that comes from the hair, because in the next step that I want to present, we will actually apply strand-based hair on top of that. So we only capture from -60 to +60 degrees actually. And to get the full head, one of the biggest challenges is to get a good, decent hairstyle. More like traditional photogrammetry scanning under studio. So what's very commonly done is that you just ask a person to wear one of these wig caps that keeps long hair out of the way. And then there would be a 3D artist that has additional reference images of the actual hairstyle of the person, and then the hairstyle will be groomed manually from scratch. For the kinds of applications we are doing, the users expect to have an avatar immediately, so everything needs to be automated, obviously. But by far the most detailed method are actual hair strands. You're actually representing each hair individually. The most naive approach would be, okay, we also train a model, just takes all of these images as an input, and we just predict the hairstyle directly. You get a hairstyle that's quite close to your actual hairstyle, but it misses like this subtle detail. We added another step. We first extract certain features. We then use both of these, and we run an iterative optimization. And this way you actually get a more personalized hairstyle that's just closer to the hairstyle of the person that's scanned. These are some of the results. So in the CD avatar with the hair strands and everything applied. And I'm actually pretty happy with how the hair strands, with how the hairstyles came out here. Our default avatars are just 3D mesh textures, hair strands. They can basically be deployed into any real-time 3D application. This is, for example, Reallusion Character Creator. It's a character creation tool for developers. This is MetaHuman, where we also integrate through a plugin. But in general, we can just integrate into any existing character system. Called AI avatars, where we take the same 3D proxy, basically the same geometry, but we apply some neural rendering on top. So we have a neural network that's trained for each individual person, trained on a video of the person to resemble the person even better and give even better realism.